So Victoria,
Thanks,
so
Maria.
in the hub, we will see students who are undecided. We'll see mostly freshman students, and a lot of them will have questions about the different curricula in School of Engineering, and they may say to us, you know, why would I want to be a civil engineer? What kind of skills should I have? What's the discipline about? So we thought we'd talk about a general discussion of why would someone want to be a civil engineer.
That's great. So that's how I wanted to organize it today. I'm going to just stand up for a little bit because I want to be dynamic. And so the organization is similar to what you just suggested. I was hoping that we could talk in general about civil engineering and maybe open your minds to what civil engineering is all about. I had, you know, a little bit of concern about this session just because I feel I have only an hour to pull you in and get you to buy in to civil engineering as a degree program. We're a small department, and I wish that we had a way of, you know, recruiting students and maybe a desire to recruit students also. Sure. So I've talked to Marie a little bit about that, but my slides to start will hopefully be a little bit of motivation towards civil engineering, and environmental falls in, and we'll talk about how that works, and Barbara already had some questions about the intersection of those two departments or degree programs. We're one department, separate degree programs. But mostly this will be geared towards civil engineering. I also agree that the handbook has actually some good stuff, and I've pulled the same stuff out. So if you
Great.
don't need to, so you don't want to flip through your binder,
Awesome.
I've
Thank
pulled
you.
the same template and the helpful hints, and then the flow chart that I actually don't spend that much time with, but some people think this way, so it's helpful for others. I want to just start out by saying that you have a great resource already in Jack Riley, and I would really encourage you, if you are feeling lost and something that I said just is getting pushed to the back of your minds, that I would defer to Jack on nearly everything, and I do myself. So I am always at his door saying, this student, blah, blah, blah. But you know, I think sometimes it helps to have a new face come in and say a few things about things in general, and also we'll talk about the different concentrations, but I'm a geotechnical engineer and Jack is a transportation engineer, so you do have different perspectives from that side. When we talk about the go-to people, I've put him as one for transportation and the general curriculum. I put myself and Tom Zimmy as geotechnical engineers, so there are folks. And actually, I wouldn't be uncomfortable to direct students to anybody in our department. So that I also would emphasize as a benefit of being a smaller department here at RPI. So my background, and I guess maybe you wouldn't have known this, but Elizabeth was saying that you might be trying to get grad students and faculty from different departments to get the perspective from either side. I was a student here for all of my degrees, bachelor's through PhD, through postdoc, and now they've got me on the faculty, and I am just clinging to my office for as long as I can. So I have seen both sides, and obviously things have changed over that time. So even when we talk about the template and the curriculum specific stuff, it is different from what it was when I was a student, and it's fluid with ABET requirements and different developments on the department side as well. So I think sometimes, you know, I even am going back, well, in my time, and even though it was 16 years ago, it's still, you know, we tend to get stuck into what we know. So the handbook and the information on the website would be updated and would have the most current information. Because I guess I also don't really know when this change, you know, the core advising change will affect us, possibly next year.
Possibly.
That's the plan.
That's the
for
plan.
Next year. So, you know, even a year from now, some slight tweaks might have come. So I'm going to try to get some interaction and ask you the question what you think civil engineering is all about. Jack, I'm taking you out of this because that's cheating if you answer. But just some thoughts. I mean, this is the same sort of thing I go through when I have high school students come in and talk about our program. I ask them, and they're also reluctant to answer, but I would be happy to hear some perspectives on what you believe civil engineering is all about.
Say it's not fair to ask me. My dad's a civil engineer.
Well, that was going to be
ringer.
You're right. That was going to be my follow-up question: is do people have relatives that are civil engineers? And it's one of the oldest engineering professions, I would say, and we tend to have a long history, and a lot of folks who have backgrounds in civil engineering. So what did your dad do?
He worked for the New York State Department of Transportation, and oddly, this doesn't sound like a civil engineering thing, but his specialty was like guardrail, guide rail, and I call it duct work, but like the sewer planning along the roads to remove the water from the roads.
Sure.
A very important thing.
It's a very important thing. So what the students usually say are, buildings, we build buildings, and sometimes I still get students who are associating engineering in general, so you work on trains, you're like an engineer, a train engineer. So I like to at least start them thinking about what civil engineering is all about. We do have a very old department. We've done 175 years plus now. We celebrated our 175 years of civil engineering in 2010, so now we've been some time removed from that. But we are not just about buildings, and that maybe is going to be the emphasis of my talk today. So we have 4 concentrations, and we'll summarize them here: structures, geotech, transportation, and environmental. The majority of our students come in identifying themselves as structural engineers, and that is because that's what they see. So it is the buildings, it is the bridges, it is the structure, the built infrastructure that we're creating as civil engineers, but we have not yet figured out a way to anchor buildings to the clouds. So we have to have some folks who are trained in the part that puts the building on the ground, and that's our geotechnical engineers who are designing the foundations of buildings. And then we also have, Jack's specialty in transportation engineering, and we do tend to employ a lot of students in the departments of transportation across the United States. They're going to have not just transportation engineers, but also geotechnical engineers, structural engineers, environmental engineers employed within there. And it sounds like Dana's father was also at kind of an intersection of those disciplines. He's dealing with water, he's dealing with the actual physical structure of the guide rail. So if building, infrastructure, dealing with people is what civil engineering is all about, what kind of challenges might we face as civil engineers?
I think of civil engineers whenever I'm on a crazy on or off ramp of a highway. Here, you have 3 inches though, like I'm a jumper.
Right, so layout and planning, and how do we also deal with what the ground might provide for us as far as sound foundations when we're putting those on and off ramps.
Climate.
Thanks, Marie. So not just climate, but also these kind of extreme events. And I think that this is the way to really attract and get some forward-thinking students into our department, because it's not just that we are building this environment, we have to building this built environment. We have to have this infrastructure in a setting that is constantly under siege from the environment and extreme parts of the environment. So natural hazards and hurricanes, tornadoes, landslides, floods, and we'll look at some of those in particular. So we might say, well, could it really be that bad? And I show this video to students, and it still doesn't fail to impress. And, fortunately enough, we had some monitoring in place at this location, and they were able to say, we're going to have some problems here, and in an acceleration of the displacements. And really, I think it was just luck that they were able to block off. You see the barricades on the roadway there, and from that first camera angle that they had concrete barricades at the edge. And so it was, I think, just lucky that it was that close to where they had blocked off the road. But we are also trying to monitor the environment, and that's my big thing, and I think that it's going to be increasing in the future. So we have this infrastructure, the roadway, that the public is going to be using, but we also have the environment competing with our designs.
The Albany sinkhole.
Sure, yes. And there are plenty of examples in the landslide category alone. This one is in Italy, and I show this because it also has the angle of interacting also with people, emergency responders, who are going to be critically linked to civil engineers. And they're trying to get folks out of this area, and you'll see, okay, this is time, we've probably given advance warning, we probably have sent out some notification, but yet this has been going on, and we'll still see after the video progresses that, they're all of a sudden the Mercedes start coming out of the neighborhood. So there's this interaction with people that I think is a little unique to civil engineering, because maybe you have a whole separate department when you're providing parts or products for the mechanical engineering industries. But here we're having kind of large-scale issues that are going to affect the public, and in some cases in a time urgent situation where we can't take a lot of time to say what's our public press release going to be to this issue. That might be, an automobile industry could do a recall on a product and have a really formalized response, but here we're having to make reactions on the fly. So here's folks coming out after this video has been going on for quite some time already.
Shaking. Oh, should leave.
Yes. And to give an idea of the scale, this is the Google Earth image of that area in Italy before the landslide. This is afterwards, so 0.8 of a mile, and we're watching the Olympics these days, but so we have a little bit idea on distances, how far that might be, but 0.8 of a mile would take out RPI's campus, really. Could go across from College Avenue to Hoosick Street. We also, as far as extreme events, we could look at tsunamis, and I think, again, it's going to be not just what happens during the event, but also and how the structures respond, our structures and foundations, our earth environment response during the event, but also post-disaster. Our transportation group, headed by Professor Jose Holguin-Veras, has a very robust research activities in post-disaster response, humanitarian logistics, so how do we get aid to folks who really need it after an event. And for a long time, earthquake engineering has been at the forefront of our research department. We have a Center for Earthquake Engineering Simulation, and that revolves around our geotechnical centrifuge, and we could talk more about those kinds of facilities, but I think hopefully the idea is that we're building them up, and then the students are coming to faculty in the second 2 years, and that would be really the time that we want them to get really heavily involved in those kinds of research departments. But we'll talk about that's an option even as early as freshman year. So I put this last one up, and maybe we can do one more just to keep you thinking about the challenges. So we're not just dealing with natural disasters. In this case, this was Teton Dam, and you can see here, so this is all earth here, and that's holding back water. This is as the failure's progressing, so from a different angle, but that is this pile of earth now degrading even further, and this is the same spillway, but this is where the dam used to be here. So there wasn't an earthquake, there wasn't a landslide. This is just the design. The design has to be done properly, and when you're dealing with earth materials, you don't always have all the specifications down to to this very significant figures in order to make that design work. You're also providing a design to a contractor who's then building this structure, and if we don't have good quality control of the construction activities, then we also will run into problems. So I say, when I do this with students, I say, okay, if this is what challenges we face, then what can we do to overcome these challenges? Well, we can get good training as civil engineers at RPI, and we can also do research in these areas, which is what our group is doing. So I would point to these as the 4 concentrations that we focus on in civil engineering. I will just quickly go through the highlights, and then we'll talk about the curriculum in specifics. As I mentioned, structural engineers are going to be the majority of, the mindset of the majority of students. This is just a little comic about, you know, how do we do design, bridge design. And I have to say that actually most of the time when I give this talk to students, prospective students, high school students, then they, well, how do you do it? And so they are curious and they want to know. And I will say, you know, sometimes though there's only so much, oh dear, there's only so much that we can do when we're designing structures. So we do put limits on our facilities, and we have done some mechanical analysis of the system and said, okay, this is a 3-ton capacity bridge. But again, we're interacting with the public, and everybody's decision process is going to factor into how our systems get used, so we can have these kinds of incidents. Because students so often identify, or students do so often identify as structural engineers, I think because the structures are so visible, the buildings and the bridges that are these systems that they see out in the world, that isn't necessarily a bad thing. It just means that strength of materials becomes a critical course for our curriculum, because it's a prerequisite for the Intro to Structures course. If they don't get strength of materials in time, then that pushes back the Intro to Structures. And if Intro to Structures gets pushed back, because that's only offered once a year, it's not every semester, then we would have a delay, a further delay in the program. So because it's the majority of our students, that does become a critical piece. And just as a, if I can advance this one. Oh, it won't let me do it. So the Tacoma Narrows Bridge is another example of how we really need to have design properly for the environment. And then maybe I can do it. Maybe I can cheat this way. If you haven't seen it, it's worth watching. Well, it won't let me do it. So the bridge was maybe pretty well designed, except that we had this condition where the wind was blowing nearly perfectly horizontal to the ground. It had these huge girders, and it started into this mode of vibration where it was just going this really slow vibration and ultimately failure. So again, this is the case where we need good design and we have to interact with the environment. So I'll quickly say about the other concentrations. Again, as far as transportation engineering goes, I would defer to Jack. I always show these slides, Jack, and I say, well, I wish I had really more to say about this. But I think, you know, Department of Transportation, just because it has transportation in the title, becomes a clear employer of those kinds of students. But they're not just going to be looking at you know, pavement design, and in fact we don't do very much of that here, I don't think. They're not going to just look at the pavement design, but they're also going to look at the facilities. How does the layout of roads happen? I mean, the interstate system in the United States, I think, is pretty well established, and we don't have very many new highways coming. Is that fair to say, Jack?
Absolutely, yeah.
So it's kind of unique when you do have a big highway project, but we are going to be updating our infrastructure. And I think if you see any thing on civil engineering, it's particularly about what are we going to do with our crumbling infrastructure, and that encompasses both structures, bridges, and how the buildings that are supporting these facilities, but the roadways and everything that go along with it. And again, I think that I want to emphasize in my talk of our curriculum that there is a lot of overlap between the concentrations, and you specifically have a question about, is there a recommended concentration? And my emphatic answer is no, there is not a recommended concentration, and I would actually encourage students to be broader in their backgrounds. And, you know, this is kind of literally the intersection of transportation and waterways engineering, but I think we would do well to have students who have backgrounds on several fronts. And we have, you know, some local examples of transportation and structural engineering in the Twin Bridges, though I will say that I do the same as Lee and say, what were they thinking? And I'm commuting back and forth. But I think there's also the issue of scale in civil engineering. So this is the Hoover Dam bypass construction, and it's really, to me, still amazing that you start and it's more than just hope that brings you together in the middle. So this is the kind of scale that civil engineering students could think about, that it's not, you know, under the microscope and things that you might design but never really see. And I had a hard time embracing that kind of, you know, the electrons, what? The electrons are doing this, but here you're going to design something that could be on this scale, and you're going to really see it in the end. And some of the things, if you did do some looking into civil engineering, the language would say, oh, you want to leave your mark, you know, you want to build these big structures, and well, maybe and hopefully we're getting to a point where we do, and we are going to continue to build these kinds of structures, but we're also being mindful of the environment when we're putting that infrastructure out there. Our environmental engineers, and Barb was touching on this point, that, you know, water treatment, sewers, wetlands, protecting the ecosystems, taking care of contaminated sites, that's all going to fall under the purview of environmental engineers. We have an environmental engineering concentration, so we can make some distinction between I'm getting a civil engineering degree with a concentration in environmental engineering versus I got an environmental engineering degree. And the big difference is going to be the chemistry. So the environmental engineering curriculum, I think, is chemistry heavy, and civil engineering students tend to shy away from it because of that.
Got you.
And the fourth of our really defined concentrations is geotechnical engineering, which is what I identify as. And this was from not this most recent graduation, but the one before, where you know, this is how some of my students identify it themselves, that, well, my geotechnical engineering degree is really about playing in the dirt. And I think that's what makes it fun. You know, it is really hands-on, and you'll have other faculty who say, because we have to, as I say, we're not putting buildings into the clouds, we're putting them on the ground, and we have to know about the ground that we're building them on. And think about how hard that might be, because it's formed millions of years, and what is here underneath, you know, if we took a column down into the ground right where I'm standing, could be very different from what is even where Barb is, or even worse where, you know, the field is over here. If you see the rock outcrops at the edge of 87 Field, is that what we call it? But yet there's grass, you know, just 10 feet over. So it's a very different there's very different materials, they're very different strengths, and we have to be able to find out about that, but it's going to cost money to take cores into the ground and then take it back to the lab and do tests, which is what we do. That's the reality of it. But with that uncertainty comes a lot of creativity too. So you might find that students who are not wanting to just, okay, I know how to design this part for this automobile. Maybe they don't want it to be the same time after time after time. And I think that civil engineering is going to be a field where you have to be creative in your solutions because it's not going to be the same every time. Very, very, very rarely the same. This is in Christchurch after the earthquake there, and so playing in the dirt can sound kind of fun and intriguing for kids and for students, but it also is the reality that's faced after these kinds of events when we have liquefaction effects, and now we're not just playing in the dirt, but we're dealing with the dirt that has come up after these earthquake events. So we could look at some geotechnical engineering if we're thinking about the ground and that we have to build into this really uncertain material that we don't have very well characterized. We could say, okay, what would I show a student as a geotechnical engineering success? And I would say for sure, MPAC could be a very local geotechnical engineering success. You know, we put a little drama into it and remind ourselves that this is what the road looked like in front of the Carnegie Building before, not that long ago, 2 summers ago, before they did the sheet pile repair, and now there's a new facing on it. And so what they did this summer is just cosmetic. What they did last summer was important structurally. And I had taken students down to this location and just to say, okay, I'm looking at MPAC in the background, and obviously I have unstable soils in this area. So what had to be done to shore up that edge of that building in order to make sure that it continues to be a success? And what it is tiebacks about 1 million miles long into the soil. Well, I bring in a speaker and it's like, well, those are the longest tiebacks in the United States. I mean, it might be certainly in New England, I think, to keep that structure sound. So that's what geotechnical engineers are faced with, and I think that it does become an attractive field because of that it's not just every time I know what I'm dealing with. Really, every time I don't know what I'm dealing with, I'm starting from square one and trying to get information out of the soil and then looking to historic information. In the case of that landslide, they would have said, this is an active landslide zone, and we have some prior information. I think that's how they constrained it so well with the concrete barricades there. To touch on research, just because this is in my wheelhouse, we have the centrifuge on the first floor of the JEC. We use it for physical modeling, so we're building actual models and we're spinning them in a centrifuge. Some of us have some centrifuge, an idea about a centrifuge, I think, from the medical fields of separating blood. The idea is that it's spinning, but in our case, we're building models that are on this order. And what we're trying to do is just make the model simulate full-scale conditions. So it's similar to the way a wind tunnel is used. And the centrifuge is the tool to make this model behave as though it's the same as a field condition, and then we can do anything to it, nearly anything, to study. So we could have a levee model and flood it and see how it reacts. We could have a soil deposit with a pile foundation and we can shake it as the same as earthquakes have come through California and other areas. We can put that same input motion in and say, okay, if we had this different foundation, how would it have performed? So the centrifuge is just the tool to make the model simulate full-scale conditions, and then we can test it for what we're interested in studying. And if you're thinking also in terms of geotechnical engineering, I recently gave a talk to the Department of Homeland Security, and they are employing a lot of folks that have civil engineering backgrounds. They are interacting with FEMA, and I mentioned first responders. I put this slide up and I said, how many of you in the room remember where you were on this date? And nearly everybody in the room knew where they were on this date. So this is when Hurricane Katrina made landfall, and I think that drives a lot of motivation for civil engineering students. It did for me. This was when I started grad school, and we did a lot of work in the centrifuge related to the levee performance and found out some things that you wouldn't really, that the numerical modelers, so the folks that are putting simulations in computers, wouldn't have known without having this physical model test. So I'll give this one as the last video, and so now you can identify with the centrifuge a little bit. Here we're spinning at 80 G, or 80 times the Earth's gravity. And this is the model in flight. So you can a little bit see the light flickering in the background to convince yourself that this is during a test. The levee model is here. This is sand, peat, a clay on top, and then there's a sheet pile down the center of the levee. We're flooding this model, so the water height is increasing here, and as the water gets up to a certain level, the sheet pile starts to rotate. So now the water has a direct path to the sand, and you'll see it seep through on the far side long before it overtops the sheet pile. So this whole system, the whole levee system in New Orleans is based on what's the design height of the protection. It's 14 feet in Louisiana, in New Orleans. But this levee failed before it got to 14 feet. Maybe it wasn't at 14 feet to begin with, which was a problem in other areas, but at this location on the London Ave Canal, we had a levee failure and a breach of that levee before it got there because of this rotation of the sheet pile. And the numerical modelers didn't have that failure mechanism, that rotation programmed into their model. So it said, okay, yeah, there could be failure from overtopping, there could be failure from scour, other issues that happened, but unless we told that model that we have this rotation happening, it's not going to know to do it. So I think this is a clear advantage of physical modeling. I think it's critically important to civil engineering that we have physical models as well as numerical models, and this was a great way of showcasing that, because this is exactly what was observed in the field at that location in New Orleans after the hurricane, was this push of the soils over and these blocks of clay basically displaced by several feet, and then obviously the flooding in that location. So I hope that gives some motivation about civil engineering, and then I'm happy to go through the questions. I think Jack and I talked about what the important takeaways would be, and a lot of this I would imagine if I had to embrace the electrical engineering curriculum, for example, I think it would be overload as far as information. So for us, what I mentioned at one point is that strength of materials is a critical course. So students should take strength of materials as soon as possible in their curriculum. And then I would emphasize the point that we're a small department, and I think they're going to get great service with us and a lot of access to faculty, a lot of welcoming faculty in the department. So I would say a student who is wanting to get hands-on, wanting to see the results of their designs, wanting to have a little more intimate interaction with the department, I think they would be well served in civil engineering.
Awesome. So you mentioned at one point, Victoria, about you're a fan of students having a diverse kind of, not focusing on one concentration, right? So in your curriculum, does that play out through those design elective courses?
Yes.
And they choose those, right?
Right.
I mean, my guess is knowing students that some of them would be like, I want to be this engineer, so I'm going to take all those classes, right?
Right. And what I would, so that answers two questions that are in your list about, one, you know, is there a recommended concentration? And two, what do you recommend for free electives? And I would say emphatically no, there isn't a recommended concentration. And that I would advise students to take civil engineering courses as their free electives. So that's where they're going to get that breadth, I think. So we do need to have depth in order to succeed in the capstone course that Jack teaches, and that would be the design elective sequence. So if you see in the third year CE design electives, they have the superscript for 5, and it's saying text below lists the allowable courses. And if you go to the catalog for capstone, it's going to have some specific language now, right, Jack, about what you need, the prerequisites that you need for capstone. So you need a lot of things, but basically we should have something in mind that capstone is going to be the culmination of our degree. So really you should have everything before you get to capstone, right? But you need to have the 2 design electives in the same swim lane. So we would have typically for a structural engineer that would be steel design and concrete design. For a geotechnical engineer that would be experimental soil mechanics and foundations. For a transportation engineer, that would be highway engineering and traffic engineering.
And that'd be a good selection.
And the environmental engineering concentration is not that popular, but we do have the option for that, and the courses are listed there as well. You might do well to think a little bit about that sequence there. So I would recommend solid and hazardous waste and geoenvironmental engineering, and that's crossing between geotech and environmental. But for the few students who are trying to get a concentration in environmental engineering, I would say they might already have in mind what they're interested in, so they're going to have a selection made out of that list, but I would refer them to the faculty to make a good choice there. So since we're into the curriculum, do you want to
Sure,
just go
for
through it? As I mentioned, strength of materials becomes the critical course. The first 2 years of our traditional curriculum are, I think, I haven't looked, but I think very similar to the majority of engineering's, right? We're trying to get them through the math and the science and the core, and we aren't having anything civil specific really in those first 2 years. So we don't see them, we don't identify really with them until they start their junior year. We do have this 1 credit Intro to Civil and Environmental Engineering exploratory course in the spring semester. I think it's solely offered in the spring semester. We could replace that with engineering processes. We recommend it to our students. I would recommend it to undecided students.
So it's open to all then?
Yes.
Great.
Yeah. And that really is the only civil course that shows up in those first 2 years. Strength of materials shows up in the template in that 4th semester. I would say it doesn't hurt to push that up, and it is a help to push that up. You could see both sides on the advising of that. Our Intro to Structures course uses the first exam, or the final exam of Strength of Materials as the first exam in Intro to Structures, more or less. So some students might prefer to have it fresh in their minds, but you run the risk of, which happened this past semester, we had 6 students fail Strength of Materials, which is a prerequisite for Intro to Structures and Intro to Geotech. Those intro courses, which are the lead-in to our the meat of our civil engineering curriculum, are only offered once a year. If you miss those in the fall, you wouldn't have the background necessary to start your design elective sequence. Everything would be delayed a year, really. So that's the other part of a small department, is that pretty much our courses are offered once a year.
So the 6 just delayed a year?
Well, 2 of them were smart enough to catch it over the summer, which it is available. We can make exceptions.
Is that part of your summer arch? Will that be?
It's taught every summer.
It is
Yeah.
always.
Yeah.
Okay.
All of the core courses are.
So in that same breath, I would say, for me, I am much more, I teach our Intro to Geotech course, and I'm much more flexible than perhaps others. But even our Intro to Structures instructor has said he will let them take strengths and Intro to Structures concurrently, as long as they didn't fail too badly. So, yeah, you could make a judgment call on that. Again, so a lot of my answers, which I should have said at the top, that I would like to have the ability to revise. So what you have here isn't maybe my final answer to some of these questions, but a lot of my answers do say I would talk to the faculty. So I would hate to see a student delayed a year. So though it is a prereq, I would say let's be reasonable in our reaction to students.
I mean, you can make an argument that even though they failed strength materials, they hopefully sat through the entire semester, right? And, kind of were at least exposed to the material, say, right?
Or if
So
they
that,
want to be in civil, just tell them it's the flip, IED and strength. And
Sure.
I-
Yeah, and then you
strength-
have a cushion. Yes.
Strength in the fall,
Yeah.
IED in the
That
spring,
way you got
because
another shot at
the
it.
only prereq for strength is IEA.
Right. Yes.
Yeah.
And because it is a prereq for 2 of the 4 of our intro courses, obviously that is one where there was one question about if a student likes a particular course, they would do well as a civil engineer. So I don't know that there are that many students that would say they liked strength of
that's
materials
going to be my comment.
or IEA, which are the 2 that I would say, but those are very much civil engineering lead-in courses.
Yeah.
So do we feel fairly confident on the first 2 years? I mean, they're pretty
Yep.
universal. And the humanities piece, I feel that you all who have been dealing with students coming in and asking probably maybe some, if not, a lot of HAS questions maybe about, am I meeting the requirements, am I checking off the boxes? I would say you all are much better suited at figuring that out actually than some of my colleagues. So the HAS is interspersed, that part I don't have much specific to say. They do sometimes have some exploratory STSS courses that are environmentally minded, so those might be interesting for some of our students, but I wouldn't exclude that. I think the majority that I see do a psych sequence and then an economics something on the other side.
What I noticed here is that 4 of the 5 required COS classes are taken in the first 2 years. So if the student has chosen unwisely,
Yes,
there are real serious problems.
that is true. I think they do get shifted around when the AP credit comes into consideration. So, and I do have some that are trying to, I want to interject some HAS in the meaty part of the curriculum.
I'm not.
I think.
An observation that for those of us who will be dealing with students in their first and second year,
They have to get it
we need
right.
to make sure that they are getting it right, yeah.
Sure. So then when we move into the third year, those 4 intro courses are really the way of giving them some background on the possible concentrations. And we do also see students shift them around. So if you're coming in with AP, you would probably be able to move things up. You could and maybe, I'm not sure of the numbers, but you could move strengths into that first year, and you would have the option to start some intro courses as a sophomore. And I've seen students doing it. I've seen students come in with the max AP, and I have one now who could do the co-term in 4 years.
Wow.
Right, by moving those she didn't move all of them up because she's a structural engineer, but she selectively moved some up. So that's possible to say, I really know that I want to do structural engineering. I'm going to move up. I've taken strengths in my second semester. I'm going to move up intro to structures, and I'm going to start my design electives in my 4th semester. That would be okay. But the majority of students are going to follow this. They'll see all the concentrations, and then they're going to start making choices on what they put into those design elective slots. So that's where they're identifying as structural, geotech, environmental transportation. But again, I would say your best option for employment is to have some background in other things. I have my best friend who I came through RPI with, she was interviewing for a highway engineering position at a consulting firm, and all she had was on her resume, relevant courses. Even the students put that on there, related courses, and she put solid and hazardous waste and geoenvironmental engineering in there, and the HR department said, well, we're also hiring in our solid and hazardous waste group, and she has been designing landfills for her whole career since she left RPI and loves it. So it was really only because she had taken courses outside of the concentration that she was able to go into that field. So that's where I would say the free elective slots, we all are challenged by fitting everything into these 8 semesters, and ABET is saying you need to do this and that, and so we all would want to do more with our degrees, and I think that seems to be the message that we've been advising students, is that free electives should be taken within the department. Obviously, you do want to relax your mind a little bit, and maybe you're taking, do we still do African drumming? Or
We do.
Yeah, so maybe you're putting those in there as well, but that would be our recommendation.
Now, is that first semester where you have those 4 intro classes, is that a super intense semester because they're all technical, right?
Yes.
I mean, I wonder if that, do students perceive that as, a tough semester, that your first entry into the major?
I think the problem tends to be more the way we sequence, but aren't 3 of them done in one day and consecutively or something?
We've addressed it.
Okay.
So yeah. So no, it's meaty. So
Yeah.
I have a lab. Structures has a lab.
Okay.
And it becomes a lot of material that they have to produce. Transportation does a project or several projects.
Yeah.
Environmental is all chemistry, and they hate that. So it does become meaty, but there's also, so the majority are doing this, following this sequence.
Yeah.
It also becomes a time for camaraderie. So that's where you're seeing the same people in the same 4 classes. You're going
Through it together.
Yes,
in the trenches.
And we've broken it up, so we don't have the 2 lectures back to back. We've broken them up with a lab. It's 2. They are also switched, so they do 2 lectures on Mondays and Thursdays, 2 different lectures on Tuesdays and Fridays. But yeah, they're slogging through it sometimes.
I would imagine they think it's called intro to something. It should be easy.
Oh yeah, they figure that out pretty quickly. So the important sequence to getting to capstone again is that we have to have 2 in the same swim lane so that you can contribute meaningfully to capstone. because we are trying to get some kind of system design, and we want to have folks who would identify as structural engineers, also some folks who identify as geotechnical engineers, and transportation engineering sort of is handled
That
separately.
one is subtle, because in the curriculum, it doesn't say you have to have them both in the same concentration area, but as a prerequisite for capstone, you have to have them both. I do the capstone in our department, and the first day I sweep for outstanding warrants, who's compliant and who isn't. And typically there's 5 or 6, and I choose to be flexible on it, but I want to know who can do what. But that is more for the academic advisors in 3rd and 4th year. I wouldn't be too concerned about that at this level.
Right.
For freshmen and sophomores.
So I don't know, we're maybe 10 more minutes. The other elective piece, though I would agree with Jack that they're not, I think we would see them before they would fall into that category, is the tech elective. And those are also listed there. So those could also be courses that are injected in free elective slots. And one concentration that isn't really explicitly said here, but that I think students are tending to identify with, is construction. And construction management is a course that falls in as a tech elective. I would say that and professional practice are both important, so that could be one or the other that they're injecting in the free elective slot. But if a student is, my dad owns a construction company, we've been getting a lot of these actually. My dad owns a construction company, he wants me to get a degree, but I'm going to work for his construction company. They are, I would say, wanting to take structures and geotech courses. Is that fair, Jack?
Yeah, I think that's quite reasonable. You're right, there are a lot of students who enter because there's a construction business in their family and they want to begin that business somehow.
Right. And really what they're, a lot of students are going to be, a lot of civil engineering students are going to end up being managers. So if they identify as a construction manager or a consulting manager, I think that's the forward progression. So they're doing design for the first 5 years, and they are getting their PE license, which is one of the questions that the fundamentals of
Right.
engineering exam
Yeah, I wanted to mention that.
is a must for our students. So they're doing design in those first 5 years on the job, and they're getting their PE license, but then they're most likely be moving up the management chain also, doing less design and more managing, which then also, makes communication and teamwork and interacting with people a critical piece of being a civil engineer.
When do students take this FE exam?
They have recently changed the way they administer it, so they can take it, it's an electronic test, they have to go to a facility to take it, but it's not that it's offered only once. So it used to be that it was offered in April-ish, and also in October, I guess. But we used to do it that everybody took it in the last semester, or everybody was basically planning to do that. We offer, our Chi Epsilon chapter in our department offers review sessions in that spring semester leading up to it. But I think what a lot of students have been doing recently is getting through commencement and then signing up to take the test a week after commencement, around that time frame.
I can add just 2 very small things here. There's a science elective in the School of Engineering. I suggest our students take geology because it maps reasonably well to civil engineering, at least on the geotech, practical structural side. And in terms of humanities, arts, and social sciences, our transportation students are enriched if they take courses in economics. That's a fairly natural thing. But again, those would affect the first 2 years.
Sure.
Because we put more of the HSS courses then, as Dave identified.
So I'll update that and make that note in my response. And I would also say I do the same for our basic science. You'll see that we have a basic science and a math and science. So this is an ABET revision. Our basic science, I do the same. I recommend geology. Had a pretty positive response to that. There's Geology 1 and Geology 2. The slot that our basic science shows up is in the spring. That's the Geology 2 semester. It works out fine. It's not that Geology 1 is a prereq for Geology 2. They're separate courses. The Geology 1 is deep earth ideas, plate tectonics in general. Geology 2 is surface, and I think that relates very well for soils and structures.
Yeah, Earth and Sky was not enhancing their career prospects.
Yes, though it is a possible option. Because superscript 2 is pointing to that basic science elective, and it can be anything in a 4-credit course in Earth, and that's where you find Geology 1 and 2. Biology, we tend not to get that, but if a student, there are some biological processes that would be related to soils, for example. So if they were forward thinking in that way, or biology interested, which is rare, I think, for our students, they might want to take biology there. And then I always have trouble, is it astronomy or astrology, but that's where the ASTR falls in. For math,
Do you recommend something for the later on elective then?
right, so I would say you could have the same, you have those same options. So if you wanted to catch Geo 1 there, that would be an excellent recommendation. Multivariable calculus you would do well if you're considering grad school, I think,
Okay.
to get a little more math.
Multivariable
Calculus. Just because we've now put math in the options, that could be what goes in there.
That all makes a lot of sense, Victoria.
Yeah, that's good. So since we only have 2 minutes left, that's about all I need to talk about Arch. So I spoke previously with Marie. We are not participating in Summer Arch until it becomes mandatory. So.
Who knew that was an option?
And the word is going to get out now, I think. But so we will follow this curriculum. I didn't know that we had an Arch curriculum in our handbook now, but what I've given you in my handout, but what will be updated, is the primary curriculum, and then I guess we will look to the one that we've mapped out. What we are moving into the summer is hydrology and hydraulics, which is a required course that's now showing up in our spring of the 3rd year. What we also are doing, and it will be a big shift, is moving all of those intro courses to the spring of the sophomore year. So that will be great from many aspects because we will see our students sooner and they'll have more time to get into the meat of the curriculum, but it does become an issue for transfer students. And I think that that is a whole separate advising question. Jack and I have talked a lot about it. You know, because we have now 3 years before we're going to actually do something on this, we're going to be operational, I think we should have more conversations about that, because I see transfer students as a great resource, and the higher our tuition goes, the more students that probably are going to be looking to that option, but they would not be able to finish in 4 years with our courses. Those courses that are only going to be offered once a year are now showing up in the spring of the sophomore year because they need strength of materials before they take those. Those would only be offered in there. So either we talk to community colleges and say, maybe they only want to do 3 semesters and come to us in that 4th semester, or they might be excellent candidates for a coterminal degree because they could do a 2+3 and get the coterminal done in that way. So
And
I
that
think-
also gives you a little less time to get strengths in too, right?
Sure.
So, then that really becomes even more critical.
Right.
Cool. So we do have a minute or two. We'll make a minute or two if anyone has specific questions for Victoria. I thought that was great.
Marie pointed out the helpful hints. I think those are great. Those are basically saying what I said. Strength of materials and our intro courses become these cutoffs. If we aren't getting those in, then we can't get them through in 4 years. I also am not fully operationalized on summer arch, but I think if we embrace our existing curriculum for now and then look to what will happen in the future, I think we'll be fine. The sequences are basically the same, and we've pointed out, but the fact that we're moving all those intros up will mandate a fall away. For away experiences, you had a question about research. Our recommendation is internships, and so they are not actually all that well served by the career development folks. Our students are not going primarily to Fortune 500 companies, so they need to do a little bit of boots on the ground kind of searching for internships, but that's what I think they should be doing in the way semesters.
Does your department track where the students go when they graduate?
Loosely.
No, I was just saying because that's an
great source.
option, even like providing those companies
Sure.
the career center to say, this is where our civils go, so that
Yes.
maybe they can make an effort to contact those companies.
Well, I did a search just before I came in the fall career fair, and if you search civil engineering, several options come up. I pulled out the few that I thought, that I had at least heard of, and I knew we were sending students to. Chicago Bridge and Iron is a big one, CB&I. So that'll show up in my notes of my written responses. CHA locally, I think, is somewhat a big employer. They're also probably going to go to construction companies, and they seem to be getting some of those firms engaged in the career fairs. So they have to be, it's not that they could just walk around to every booth at the career fair. They're going to have to search out where they're going to go. And I think how it's been handled up to now is that students are doing most of that on their own, or at least somewhat talking to their faculty advisor. So they seem to be getting it done, would be my point. And as far as who to talk to, you have these go-to. I put names in there. I really strongly believe that anybody in our department would be willing to talk to students. So my emphasis would be that if somebody is identifying as a civil engineer and they really have civil engineering specific questions, particularly related to getting internships or extracurricular stuff, I would send them to a faculty, and I wouldn't hesitate to do that.
Great.
Or me specifically.
Awesome. I don't think any of us in this room would hesitate to send a student to you after today, Victoria. So with that, you have the answers to all our questions. We jumped around a little bit, but I think that was a great way to do this and a great way to enter into the curriculum, so I think it was awesome. And we have all the answers so that you can read them at your convenience, and I'm sure if you had a specific question, you could filter them through me, or
Yeah,
certainly
I'm happy to-
Victoria's
I'm happy
super
to field them.
approachable, obviously. Awesome. Victoria, thank you
You're
so much.
welcome.
That was
Happy to
great.
do it.
Thank you so much.